Okay, just looking at this question, we're just going to do another 3D trig bearing question. So the bearing of a tower from a point A, and A is on the ground, is 40 degrees. So if this is A and the tower is out there, that would be 40. Now I'm going to leave the angle of elevation and do from point B, the bearing of the tower is 300. So if the bearing is going to be 300, you'd have to draw B somewhere out here. Because 300, you have to turn from there, from north, you have to go all the way around. So that would be your 300. That means that would be 60, and also this will be 50. Now, let's go. We'll leave the angle of elevation part, and we'll just do the ground part, like looking at all of the bearings. So we're leaving that and leaving that, and we're just doing the bearing part. So I've got that part, and we've got this bearing as well. Okay, now if the tower is 30 metres high, we'll leave that because that's not on ground level, and we'll use that later. So 30 metres high. A is directly east of B. Okay, so that means that when I draw this here, I might just move it down so it looks like it is directly east of B. So there it is there. That is 300, and that's your 60 degrees, and that's your 30 in there. So now you can see in there we now have this flat triangle here, and we know that that's 50 and 80. So that we know that this in here would be 100 on the ground. So we have a triangle here that is at an angle of 100 on the ground. So here's the tower now. That's 30 metres high. The angle of elevation from A was 50, and the angle of elevation from B was 60 degrees. Okay, so that's a coincidence that 60 is there. So 60. So we have this situation now. I'm just going to redraw it here. So we have, just draw it a bit neater. We have that situation. That's A, that's B, that's directly east-west. That's 100 there. Okay, and these are right angles. That's the bottom of the tower. That's the top of the tower. We'll call it C. Well, that was 50, that angle of elevation, and this one was 60. And the question is how far between A and B. Okay, so if we look at this, this is the triangle on the bottom. So what we need to do is we need to get both of these triangles. So we've got this one, which is 60. And now I given you one more bit of information on there. The height of the tower is 30 metres. So that's 30 metres. And what we're going to do is we're going to find this side here. So we need to bring things down to this triangle where the X is. And then we get the other triangle, which is this one here. And we draw that out. So it looks like that. So that's 30. And we're going to call that Z. And that is 50. Okay, so we use these two triangles to help us find the sides in this triangle here. Okay, so we want to be able to find Z and Y, so then we can find X, and that's 100. So if we go up to the triangle at the top there, that's the tan rule. So tan 50 is 30 over Z, and then that means that Z is 30 divided by tan 50. And if we look at this triangle, tan 60 is 30 over Y, so Y is 30 over tan 60. And once we've got that, then we can come down to this triangle here. Come to this triangle here, and looking at that one, we can now go, all right, it's got one angle, so we can actually use the cosine rule. So we can go x squared equals, x squared equals a squared plus b squared minus 2ab plus c. So x squared equals z squared plus y squared minus 2 times z times y times cos 100. But we actually have what z is. Z is up here, that's z. And we also have what y is. We just found y there. So we just actually have to sub those in to our, we have to sub our z in for our z and our y in for our y. So that means that we are going to have x squared equals 30 on tan 50, and I'm going to put a square around the bracket, 30 on tan 60 squared, and then we go minus 2 times 30 on tan 50 times 30 on tan 60, and then we're going to have to multiply by cos 100. So once you put all of that into your calculator, you square root what your answer is, and you will have the distance from A to B. So you get 108.5.1, and when you square root it, you get 32.9. So 32.94 meters, which will be the distance between A and B.